Hello guys, I'm Paul McWhorter and we are here with lesson number 7 on using Python with Arduino. And in the first 6 lessons we've learned how to go in and stream data from our Arduino circuit and stream it into Python and create all types of cool visual graphics using Visual Python. Well, the 3D graphics are really a neat way to communicate sort of qualitatively data to people, but a lot of times you want your data more quantitative, and what you want to do is you want to create charts and graphs of your data. And even better, what you'd like to do is you'd like to be able to plot your data in real time. So as this data is streaming from the Arduino, you get a live graph up here showing it in Python. And so in order to do that, that's the direction we're going, but in order to do that, we need to install a library. And so I want you to go through this installation process with me, and that way we're all running on the same software. And so in order to do this, what I need you to do is I need you to go to Google, and I need you to Google on install Matplotlib, Matplotlib. And then when you click enter, you should get up towards the top something that says installing Matplotlib 1.3.1 documentation. Boom, we click on that. This tells you how to install it, but I'm going to kind of show you the quick way. If you have been going, the one thing you need for Matplotlib to work is you need NumPy. If you have been going along with me, when you installed VPython, NumPy or NumPy came with it. If you have not installed VPython yet, go back to my lesson using Python with Arduino at www.toptechboy.com, using Python with Arduino. Come down to lesson number 2 and follow those instructions, and in those instructions you will see how to install VPython. If you have VPython, you already have NumPy. Okay, now once you've done that, we are ready to install Matplotlib. What you do is under manually installing pre-built packages, you come down here to download. Okay, we want to come to this download page, and when you click on download, you come here where there are dozens of choices of what to install. You need to be following along with me on the versions of the software I'm using, because if you start veering off, then you're going to have things that don't work, and then I can't help you because you're not on the same version of the software that I am on. We installed Python 2.7, and we installed it for a 32-bit machine. Even though we have a 64-bit computer, everything runs in 24 bits. Or 32 bits. All the libraries are available in 32 bits. So we have Python 2.7 installed in 32 bits. Okay. With that, the Matplotlib that you want is Matplotlib version 1.2.0. Specifically, what we want the one is for Windows 32, Python 2.7. Okay, so if this updates here a little bit later, just make sure you're getting the one for Windows 32, Python 2.7. And we're going to click install. And because we're using Google Chrome, we get it showing up down here, and it installs really quickly. If you have a different browser that you're downloading in, you just got to go and find your download file. It is an exe, and you run it. Do we really want to run it? Yes, we really want to run it. Yes, we really want to run it. Okay, and then it comes up with this installation box. We click yes. Very good. It found our 2.7 version of Python found in the registry. That's what we want. We want to install it in Python 27, and we click next. And we click next, and we are off to the races. Okay, let's click finish. All right, if we did that right, what we should have is we should have Matplotlib installed now. And the way we can see if it's installed, we can open up our Vital. That's our integrated development environment that we're running here. That's the one that came with VPython. I sort of like it, so that's the one we run. And we type a line of code, import matplotlib.pyplot as PLT. And we usually import the library as PLT, and that way we have a real short little object that's easy to write. So as we're doing all of our functions and commands, it's a real simple little thing to write. So if I hit run, let's see if we get any errors. No, we didn't get any errors, and so it means that it loaded that library, which means we installed it right. So that is really great. And this is going so good, I can't help it. Let's create a really quick plot here. This Matplotlib is real easy. At the simplest form to plot something, we imported it as PLT, so PLT is the object that we're working with, and what we just say is plot. And then what we need to do is we need to give it an X array and we need to give it a Y array to plot. So the X array, I'm just going to say, is the numbers 1, 2, 3, 4. Okay, and we put those in square brackets. Now a comma, and now what's the Y array? Well, let's make it 2 times X. So the first Y would be 2, and then we would have 4, and then we would have 6, and then we would have 8. And then we need to close our square brackets. So we're going to plot that, and then what we got to tell it to do is we got to tell it to show the plot, PLT show. And now let's run this and see if we get a plot come up. Boom! Look at that. We have a plot of y equal 2x. Okay, we have a plot of y equal 2x. Well, let's see if we can put some labels on this thing. Okay, let's see if we can put some labels on this thing. I think the label that I want is, I'm going to put a plot.title. Okay, and I'm going to call it, in quotes, my simple line. line. Okay, and so when I put plot.title, I should get a title on there. Let's see what happens. Run. Boom. Look at that. There's my there's my title. Okay, so now I want, like, let's put a plt.x label. And this should label my x-axis. And so, you know, my x-axis. Putting it in quotes there, in the single quote, okay? My x-axis. And then how do you think we would do the y-axis? plt.ylabel. And that is going to be, let's say that we make that my y-axis. And close that and close that, and look at that, I misspelled axis up there. So now let's run it. Ooh. I misspelled it. Why didn't you yell at me? Y label. Okay, Y label. Now let's run it. Okay, boom. Look at that. So what I have now is I have my simple line, my x-axis, my y-axis. So all of a sudden I'm doing some pretty neat things here. I want to do one more just because I'm having fun. How about this? How about we make the grid true? So I'm going to make, I want a grid on here, so I'm going to say plot.grid. I'm going to make that true. All right, and this should put a grid. I like the grid. It helps me read my numbers a little better. Look at that. I have a dotted line grid. Wow. Just a couple of lines of code and I'm getting really cool graphics. This is a big help in math class too, that if you learn how to do this, you can do this in math class. All right. What I want to do is I want to do a more complicated thing where instead of plotting numbers, I'm going to plot a function. And remember that function, library that I was telling you that you got if you installed VPython called NumPy? I need to import that. And so I'm going to import NumPy as NP. And again, I like to use little short designators so then it's real easy to type later on. Now what I'm going to do is I'm going to create an array. And the way I can create an array in Python is I can just say X, and I want it to be an array, and what do I want in it? Well, it's an empty list. Okay, if I wanted to create with numbers, I could say 1, 2, 3, 4, like that, but I'm just going to create an empty array. And then I'm going to create an empty Y array. Okay, and so these are two arrays, X and Y. That's not good. X and Y, and they are empty. Okay, let's be good about our white spaces there. Okay, now let's do a for loop for I in. Okay, now I'm going to do an np.arrange, and what the np.arrange does is it sort of gives us an ability to create an array that we're looping through. And the way this works with np.arrange, you want your start value, and I want to start at 0, and then what you put in is your last value. I want to go between 0 and 2 pi, so I say 2 times, how do I do pi? np.pi. And this np.pi is just a real quick way to get 3.14159265. And so I could say 2 times 3.14.15, but it's easier, I think, just to say 2 times np dot pi. And then I want my step size. Well, I want 1,000 points because I want a real smooth curve. So what's my step size? I'm going to say 2 times np dot pi divided by 1,000. And then that's going to give me all these little, that's going to give me really small step size. And then the colon. Okay, so I is going to go from 0 to 2 times pi in 1,000 steps. Okay, because I take the range and I divide it by 1,000. This is the step size. So start value, stop value, step size when you use np.arrange. And then remember, our for loops in Python are through indentation. And so how do I build this array? Well, in my x value, I want that I want that independent variable. So I'm just going to say x. You don't say x is equal to I, because this is an array. You would say x dot append. And so what I'm doing is I'm appending I each time through the loop. Well, the first time there's nothing in x, and so then it just starts filling that in with the I values. And then what do I want y to be? And we got to keep our indentation straight here, y dot append. It's going to build my y array, and what I want is np dot sine of I. So I'm creating a sine wave, and the sine function you can get by just doing np.sine. And so there's a lot of np functions, np.sine, np.cosine, np.tangent, lots of things like that you can do. Okay, and so now I've closed that and I've closed that. That looks good. All right, so now I've created an X array, which is 1,000 numbers between 0 and 2 pi. I've created a Y array, which is the sine of those values. And so what do I want to do now? Well, let's just try real simple. Let's do a plt.plot. And then what do I want to do? I just want to plot x comma y. And let's see if I do something that simple, what it's going to do. Let's just see if that'll do it. What did I forget to do? It does not like that. What did I have a problem in my A range? Okay, let's go back and see what my problem is. I have 2 times np dot pi divided by 1,000. I have 2 times np for I in, 1 r for I in a range. And then also for it to show the plot, I forgot we got to do plot dot show like that. Okay, that looks pretty good. Now let's try to run it. Boom! I got a sine wave. Okay, look at that. I got a sine wave. I created the X array here by appending the index. I created the Y array here by appending sine of I, and then I plotted it, and then I showed my plot. Okay, what do I not like about this? Look at how it's kind of crowding up there. So I'd like to set the range. I don't want to come out here. I'd like to set my range. And so in order to do that, well, also let's do a couple of things. So what I want to do, I like to always have the grid, and so I'm going to turn the grid on because I think that makes it look nicer. So let's do that. Run. Okay, I got my grid. Okay, what else can I do? I want to set my own axes because I want to set the range of it. So I'm going to say plot.axes, and now I can tell it the range. And so in x, and I need to put this as 4 numbers in brackets. So from x, I want to go from 0 to 2 times np.pi. And so I want to plot from 0 to 2 pi. And then in the y, I don't want to go from -1 to 1 because that was crowding. I want to go from -1.5 to 1.5. Okay, and then I'm going to close my brackets, and then I'm going to close that. And now let's see, that should make it a little bit nicer. Yeah, look at that. Don't you think that looks nice? From 0 to 2 pi, and I leave a little white space, and I have a nice grid. I really like that. Okay, let's put some titles on this. Okay, so I'm going to say plot.title. I'm going to call this my sine wave. Okay, plot.title. How about plot.xlabel label? I'm going to call that. Let's say that it was time that we were plotting. Okay, and then let's say plot.y y label, and then what I'm going to call that is sine of t. Okay, now let's run. Boom! Look at that. Isn't that nice? That is just absolutely beautiful sine wave. There's other things that we can do where we're plotting x and y. What if I tell it, like, I can put in quotes here, I want a blue dot. Okay, I want a blue dot. And this should plot blue dots. So when I put like blue, and let me put like an O, and it should put blue dots. Let's try this. Ooh. I'm sorry, I should have put little o. B in little o. Blue dots, I think. Let's try. Yeah, okay. Now what happened here? Those blue dots are so close together it just turned into a line. And so let me do a lot less points. Let's do like 100 points, or let's do 50. Maybe with 50, that'll sort of show my blue dots. Okay. Yeah, now I got my blue dots. All right, now I got my blue dots. How about if I also wanted a line? Okay, if I wanted dots in a line, what if I put minus b, where was I? Minus b, like that. See if that'll give me dots in a line. Yeah, look at that. Okay, look at that. So what did I do? Under here on the plot, I said, in the quotes, B says blue, the O says dots, and the dash says put the line there. What if I don't want the dots and just want the line? I could put it like that. Look at that. Okay. How about if I wanted blue dots and red lines? Okay, I would say blue dots, and then I would do another plot. And what I would say is plt.plot. I still want to plot x and y, only this time what I want to plot is a red line, like that. Okay? Wow, look at that. Red line, blue dots. I want that red line thicker. Okay, so what I'm going to do here on the line, I'm going to come in and say line width equal 2. Make it a little thicker. All right, line width equal 2. Now let's come in and look, run. All right, so look at that. Do you see the power that we have here with this graphing thing? Can you imagine how long this would take in math class to go and do all these calculations? And so what we do is basically in a for loop, you create your x array and you create your y array, and then you plot it. So let's just say y, instead of being sine, let's say y is equal to, what if we say and I think I square things like this. I don't know for sure if that's how I do things in Python, but let me see. Yeah, okay. So you see it's creating a quadratic. It's creating a quadratic, but I need to do a better scale. I need to go from like -4 to 4, or I'm just going to let it, yeah, I'm going to go from -2 to 2. And so on x, on x here, I'm going to go from -2, and I'm going to go to 2, and then I'm going to go in steps of, there's 4 divided by 10, so that range is 4, so steps of 0.4 would give me kind of a nice step size, and then I'm creating the x array is just the I, and the y array is I squared, and then I'm going to plot it, and just on my axis here, I gotta think about that. X should go from -2 to 2, and I should go from, I'm going to go from -1 to 6 and see how that looks. And now this is not my sine wave, this is my quadratic, and I'm going to put, this is just x, and this is what? X squared. All right, now let's look and see what happens. Boom. Now isn't that neat? Isn't that neat? It didn't get that last point, and so I need to go like that plus, let's say like take it 2.5 and just give a little more room there so we get all the points. Okay, I need to go one full more than that. Let's go No, that's the step size. So I'm going to go 0.1 on the step size. That should fix it. Yeah, okay. So now you see I plotted a nice quadratic with a red line and blue dots. And so I've just given you, this was really supposed to be about installing the software, but I gave you kind of like a real quick overview of how to do some simple graphs. And in the next one, we'll really do more on using Matplotlib. Okay, Paul McWhorter, this has been lesson number 7. Hope you guys will tune in for all these lessons. Hope you will subscribe to my channel. Talk to you later.